Hi there, future leaders of artificial intelligence. Welcome to Anodiam, education that enlightens. In the last video, we have seen how a properly trained neural network through forward propagation predicts the price of a real estate given its inputs as in floor area, number of bedrooms and rank of locality. In this particular video, we are going to see how that neural network was trained in the first place. So we have this neural network and we are going to train it now with say just 3 properties for the sake of convenience and 3 input parameters of each property, say floor area, number of bedrooms and locality rank, and the output parameter which is the price. So our neural network is now going to learn the pattern of how the price actually depends on floor area, number of bedrooms and locality rank. Other than the inputs for this particular neural network, we have 2 layers. One intermediate layer consisting of 2 neurons, one for spaciousness, other for convenience, having the activation as per these 2 tables, and in the output layer we have 1 neuron for the price, and this has got this particular activation logic. Moreover, isn't it more apparent to calculate the price at the output layer from how spacious a house is and how convenient it is to live there than to directly calculate the price from floor area, number of beds and locality? Also, it is more apparent to calculate spaciousness as an intermediate parameter directly from the floor area and number of beds and to some extent locality if you consider it. And also it is very apparent to calculate convenience from locality, number of beds and floor area. Therefore, to train our entire neural network, we first need to train how price depends on spaciousness and convenience, that is the pattern of changing price according to spaciousness and convenience. And next we need to train the pattern of how spaciousness depends on floor area, number of beds and locality, and also the pattern of how convenience depends on floor area, number of beds and locality. We need to train the patterns backward from the output towards the input. So what exact factors do we multiply the activation from spaciousness by, or what exact factors do we multiply the activation of convenience by and add them up to get price? We need to find that. Also, from the inputs, floor area, number of beds and locality, we need to find the respective coefficients or the multipliers to get the spaciousness, and similarly for convenience also we need to find those multipliers or coefficients. Once this neural network is trained by these multipliers or coefficients, then if you give it a new property with unknown price but known floor area, number of beds and locality rank, it will be able to find out the exact price of this new property. This is all about training from output to input and performing the task from input to output. But this exact thing we need to do with minimal errors, like the training at each neuron level of price, spaciousness or convenience has to be such that the error of calculating the price from floor area, number of beds and locality has to be minimized. And once we have that minimization, we have the best trained neural network to perform the particular job. To go about minimizing the errors in our artificial neural network, let us start with absolutely random coefficients. Hence, for the first house with this floor area and 4 bedrooms and in a locality of rank 4, we get the spaciousness factor of 1.25 multiplied by this coefficient, which is 5, 4 multiplied by this coefficient, which is 4 multiplied by 9, plus locality rank, which is 4 multiplied by this coefficient, which is equal to 4, and then adding up this product, 1.25 multiplied by 5 plus 4 multiplied by 9 plus 4 multiplied by 1, we get 46.25 as our spaciousness factor. Applying this activation logic to this spaciousness factor, we get spaciousness as 5. That is, the spaciousness is 46.25 is greater than equal to 40. So we consider this to be a pretty spacious house. Similarly, with these coefficients, we apply these inputs and get the convenience factor of the same house as 125 multiplied by 2 plus number of beds, that is 4, multiplied by number of beds coefficient, that is 8, and then 3 multiplied by 4, and we get the convenience quotient or convenience factor for this house as 46.5, and hence we get the activation as 3. That is, living in this house is medium kind of a convenient thing. Like in a scale of 1 to 5, this ranks as 3 convenience. Moving forward, applying these parameters or these activation things like 5 spaciousness and 3 convenience, we multiply these random coefficients with 5, like 6 multiplied by 5, and this 3 multiplied by 4. Given these 6 and 3 are just random coefficients, we add up 5 multiplied by 6 and 3 multiplied by 4. We add these two products up to get a price coefficient of 42, and then we apply the activation of price on this factor 42, which is going to be 42,100,000 rupees. So we get the predicted price of this particular house with 125 square meters of floor area, 4 bedrooms and locality rank 4. We get its predicted price to be 42 when its actual price was 65. Therefore, with these random parameters, we get an error of 23,100,000 rupees. We do the similar calculations for all these houses, like the first house we did. The second house I'm not doing. You can carry on and do your calculations at your end. And for the second house, we get the error as 8, and for the third house, we get the absolute error as 18. So the summation of errors of all these 3 houses with these random parameters, we get it as 49. So 49,100,000 rupees is our total error for this untuned or untrained neural network with random coefficients. Therefore, this 49,100,000 rupees is the extra cost due to the imperfection of our neural network with these random parameters to buy those 3 houses. Now, the correct parameters will minimize this cost. How to go about correcting these random parameters? Let us decrease this thing from 6 to 5. And if we do the same calculations for all the 3 houses with this changed parameter, we see that our error has now increased to 6,100,000 rupees from 49,100,000 rupees. Therefore, if we try by increasing this parameter, say to 7 now, let us see what will be the change in price now. We see that the error has actually decreased now from 49,100,000 rupees to 37,100,000 rupees. We accept this change and we keep this parameter as 7 and start changing other parameters. Changing the floor area coefficient of spaciousness to 8 from 5, now this error further reduces to 30,100,000 rupees. The output price depends directly on intermediate factors, spaciousness and convenience. Now these intermediate factors depend directly on these inputs. Therefore, we tune the network parameters from output side to the input side, from right to left in a back propagation. And proceeding in this way by tuning from this side to this side and also this way from here to all these parameters, we now get a final network where this coefficient is equal to 10, this one is equal to 5, and these coefficients for which the error of predicting the prices of those 3 houses is minimum. With these parameters, the network can now predict the price of a new house also most correctly. These parameters are the values that are stored as this neural networks model. Therefore, when we now do a forward propagation with these parameters for a house for which we do not know the price, but we know only that the input parameters are 130 square meters, 3 bedrooms and 2 locality, we can predict the price to be exactly equal to 100,000 rupees. So through forward propagation, we now predict the price of that house. Now, I would like to add a word of caution over here that inside a neural network, exact features like spaciousness or convenience, which we as human beings can understand pretty easily, and I have used because we can conceptualize these intermediate features easily, but inside a real artificial neural network, these are calculated as functions by the neural network itself and might not always make sense to our human understanding of intermediate features. So these will be more or less kind of gray areas, and only some mathematical calculations or some mathematical features used by the neural network itself to do a certain task. That's all for today. Thank you. It has been a long video. Thanks for following along. If you found this video informative, do give us a like. Do not forget to subscribe and share. Thanks again from Anodiam.com, education that enlightens.